However, everybody, I'm going to introduce you how to view c3d files and extract data. Firstly, I want to show you these are the data we have. We have 8 charts in total, and I also include one file called chart tab description. I want to say if you want to know what each file, what each chart we did, you can open that Excel file. So the first one, you can see the description says it's normal push-up and it's done by BV. The second one is elevated push-up, is also done BV, and we have the other 6 ones is done by LP. And we have some landing, toe landing, heel landing. We have some single leg squat, double leg squat, and you can just pick any two to process and compare. Like you can compare normal push-up with elevated push-up. You can compare with toe landing, with heel landing, or you can compare bending knee with straight knee. Anyway, if doctor has any requirement, you can follow his requirement. So you can see the chart files we have is c3d file, c3 data file. It's a kind of standard format for motion capture. So we often use c3d files, and the way to view c3d files, you can search on Google, type in mokka BTK, or not BTC, sorry, BTK, and if you search it, it's the first link. Just click it, and you can find download somewhere. Go to home page. Not this one, sorry, not this one. It's not here. And you go to, that's home page, okay? And just download now. If you have 32-bit machine, use 32-bit. If you have 64-bit computer, you download 64-bit. And I also have marker system, software for marker system. I just want to introduce that Mokka is an open source motion kinematic and kinetic analyzer. It's an open source, so it's free, and it's also green. It means you don't need to install it to your computer. Once you download it, you can run it. It's a green application. And with Mokka you can visualize your motion capture in 3 dimensions. You can add some 2D charts to show your data, like the marker's position. You can see the motion capture, see the motion in orthogonal view, like top view, front view, side view. And also, I mean, it has some functions. I really love to use Mokka. And so once you download it, you extract the zip file, and it takes like just a few seconds to do this. And you see, it's very small application, just 24 megabytes. So you see, Mokka is an application file. You double click that Mokka, and then just run it. Okay, here's the interface. So open open, choose one file you want to see. I will choose the first trial we did. I think it's landing. So once we open it, and we can see a few markers, right? And we see 2 force plate 2 and 1. You can see the numbers for the force plate. You can see 3 marks over there: hip, knee, ankle, and you can give each mark a different color. I want to add some sticks or edges to the marker so we can see your thigh. We can see your shank. We go to tools, and we go to model, new segment. Oh, okay. I need to select them. Select the markers before I create new segment. Go to tools, model, new segment. Okay, and you need to pick one marker. You see the note, right? Key E, create edges on the edges. So choose one marker, Control, and choose the second one. Press E button on your keyboard. Press E. So you will create an edge between the 2 markers, and you need to give it a label. I give it a sign, and then you can click OK. Otherwise, you cannot click OK. So I will give the thigh a different color. Give it a red, and I then go ahead to create the shank segment. I choose both knee and ankle marks at the same time. So you need to have the control button pressed. I will tap in shank and choose knee, and I select the knee, I select the ankle, and press E button on your keyboard, and you can create the shank segment. So now thigh and shank, the segment are created, and you can view them. I mean, you don't have to create these 2 segments, but it gives us a good visualization of the motion, right? So the next step, I want to compute the angle compute the knee angle. One easy way to do it is first choose all 3 markers, and then go to Tools, Marker, compute angle between the markers. So you can see the angle changes as we jump on this. Excuse me, this is okay. I move it to there, and I can play the motion. You can see the angle changes as the frame goes. So you can see the x-axis frame. We start from 86.3 frame to 240 frame, and you can see the ground reaction force right over there. Boom. The ground reaction force is very huge when we jump onto the force plate number 2. I will show you with a second window analog. I want to see the FZ value, the vertical force of our force plate. I think we are jump onto force plate number 2, and I want to show you a vertical 2. So that so you can just follow. Just show you a method how to show the analog data. So the analog data is basically force plate data and EMG data. They are analog. So you can play the analog data simultaneously with the motion, and you can see the peak force happens when we jump onto the force plate. It's about 2,500 Newton, and it's pretty huge, right? 2,000 Newtons. So you may wonder if I want to see data in Excel, how I'm going to do it. So you can do it like this. One way to do that is go to File. Okay, I will show you. I forgot to show you front view. You can see the front view is more, it's more straightforward to see the front view. You can see the knee jumps to the force plate, and that's the front view. So back to exporting data, you go to Files, Export, choose Files, Export, choose ASCII text files, choose that file type, and you want to the markers to be exported, and you have the hip XYZ, knee XYZ, ankle XYZ. You don't want force plate reactions, those you don't need those. If you want to, you can check them, but I'm not interested in those. I want to have separate, so I would pick FC2, and that's because we landed on force plate 2, we don't need FC1. You can see a lot of V's over there. The V's are for EMGs. We just use one EMG sensors, so we just check the first V. That's the EMG we have on the calf muscle. If you're not sure that's the EMG singular, you can plot that singular. You see the calf muscle is activated when we jump onto the force plate, and you can see it's right. And you can double check the second one. It should be there because we don't have any sensor over there for the second sensor. So we can go back and continue exporting the data. We want to choose select FC2, check the first V, and then you want to comma separated. You don't want to write events because we don't have any events created, and we want all frames. We just don't want only the select frames be exported. We want all frames, so we can have a whole set of data. If you choose select frames, it will just give you one single data point for that particular frame. So you just click. If you have done checking all the data you want to export, you can go ahead and type in the file name. So it's a comma separated file. You type in, give it a file extension CSV files. So save it, and then you can go to your Windows Explorer. So I don't know which folder did I save. So I saved. So I go back to the mokka, and I did export again. Let me see which folder I saved my files. Oh, it's course related. So Google Drive. I save it to there. Google Drive course related. Biodynamics. I think the one I saved is the fourth one. So you can see some headers: frame number, first frame, point frequency. We did the motion capture at 150 Hz and analog frequency at 1500, and you can see the data, right? So the first column is 10, second column is XYZ for hip, knee, for ankle. We can plot them in the curves, right? You see, I think we have some data. Okay, in the end of the CSV files. Okay, there we go. We have FC2 and we have V, the EMG single. So if you plot C column, you will also plot. You choose C column. If you insert curves, you will plot both the Y and the EMG sensor. So you are plotting two different data at the same time. That's not what we want. So you want to if you want plot FC2 you just choose FT2 that column, select the data you want to plot. So it has so many frames, you have to go to the very end of the Excel file, and oh, that's the end. Okay, that's the end, and we insert curves. Oh, that's the curves of the contact force. It's very similar to what we have seen in the mokka, and it tells you it's about 250. Actually, the maximum can go to 2